In this video we're going to learn about gradient. First of all, a story. I wonder if you've ever heard of the person called Evel Knievel. And Evel Knievel was a real person. He lived into his 70s, but he was famous when he used to jump his motorcycle over things and was one of the first people to start that sort of trend. He's a bit crazy. So, in fact, let's look at his list of injuries. Okay, so this is a list of his career jumps. There's quite a lot there, and in the last column we've got his injuries. And so this goes back through the 60s, 70s and into the early 80s, and you can see he's hurt himself a lot by doing various sort of jumps there, and the bikes they used to use were big old heavy things. So there's lots of video of this, and you can see, you know, some nasty things happened to him, and he still had a long career despite all the injuries. And that ended down there, way down there. I mean, sometimes he didn't injure himself, but frequently he did. And probably my favourite one is this one here from 1977. He jumped 13 sharks on a Harley Davidson, and he crashed during the practice jump and injured himself. Interesting. What does this have to do with maths? Well, we're looking at gradient, and we can see gradient when we look at Evel Knievel's crazy work. You see, it didn't matter whether he was jumping over obstacles on his motorbike, crashing or not crashing, or when the time when he switched to his own private rocket ship and tried to get over canyons like the Grand Canyon and failed to do so. He used a ramp, and a ramp's an example of a gradient. So a gradient is basically the slope of a line. Which line are we talking about? Well, in this case here it's the slope of that line. That's the surface of the ramp, whether it's motorbike or a rocket. It's made up of the comparison of rise versus run. Now the rise is this line here, the vertical part. And it goes from the top to the bottom, and it should be perpendicular to the ground. And the run is from the start to the end horizontally across along the ground. And let's label those. Rise and run. And they give us the gradient. The important formula you need to know is written here. The gradient, which has the symbol m, is rise divided by run, or rise over run. So this gives us a couple of different situations. We can have what's called a positive gradient, where we go from start to the end and the line has gone up. That's because the rise is positive, it goes up. The run always goes from left to right, always, but the rise can go up, or in this case, from start to end, the rise can go down, and that's called a negative rise. Sometimes a negative rise can be called a fall. So, fall or negative rise. Okay, so negative rise or fall mean the same thing. So, as I said, we always work from left to right, and the run is always positive, as we said. The gradient can be positive or negative, so positive there, negative there is the blue line we're talking about. There's two other situations that you might notice there. There can be a zero gradient, and sometimes the fourth and final type is when the gradient is undefined. A vertical line has an undefined gradient, and a horizontal line has a zero gradient. Let's have a look at that and why that is. So we can see the four types of examples. The positive gradient is the one that from left to right goes up. Alright, so as we look that way, we always look from left to right. As we look to the right, This line here goes up, so it's got a positive gradient. This line here, as we look from left to right, we scan from left to right always, has a negative gradient. It's falling as we look across. The other two, the horizontal line, you can see there is in green. As we look from left to right, it's running, but there's no rise. The rise is 0. It doesn't go up, it just stays at the same height. But it still runs. So it's got a run but no rise. So that would be rise over run would be 0 rise over the run. The run is how long the line is. It'll always come out as 0 because on a fraction 0 on the numerator always comes out as 0. So horizontal lines have a 0 gradient. The undefined gradient is from vertical lines. We can see one in purple. What does that mean by undefined? Well, when you look at the rise over the run, it rises as we look from left to right. Well, it only rises. It's got a rise, which is some number, some value. It's got no run. It just stays. It doesn't go across at all. It only goes vertical. So its run is 0. You can't actually divide by 0. Dividing by 0 has no meaning. So that's called in maths undefined. When you divide by 0, there is no answer because dividing by 0 has no meaning. And that's why when you hit your calculator, any number divided by 0 will say error or something similar. Going back to an example now and doing a question, we'll go back to Evel Knievel's rocket ramp, and if that ramp from top to bottom is perfectly vertical in its rise, okay, so that strut is perfectly vertically up and down, so the rise is 35 meters in this case. The run, the distance the ramp goes across horizontally, is 15 meters. So how do we do that? We write the rule. So the gradient, or M, is the symbol we can use. The gradient is rise over run. The rise is 35. The run is 15. We can simplify that. 7 over 3. You can leave it like that. You don't need to change an improper fraction, and this is simplified. If you really feel a need to, that's 2 and 1/3. There are no units because it's a comparison of like things. It's actually just like a ratio. There's no units.